Now we have some division questions, but for these questions we're going to get remainders. That's because 11 isn't in the 4 times table, 18 isn't in the 5 times table, and 15 isn't in the 2 times table. So let's start with 11 divided by 4. We have 11 blocks here, and one way to divide by 4 is to make groups of 4. So here we have one group of 4. Now we can make a second group of 4, but then we have these 3 blocks that are left over. We can't make a group of 4. So that's why our answer is 2 remainder 3. We've made 2 groups of 4, but then there are 3 blocks that we can't share out, and this 3 here is our remainder. Now we have 18 divided by 5, so let's make groups of 5 from these 18 blocks. We can make 1, 2, 3 groups of 5, but we can't make another group of 5 because we only have 3 blocks. So we've made 3 groups of 5, but then we have 3 blocks that we can't share out. So our answer is 3 remainder 3. Now we have 15 divided by 2, so we can arrange our blocks into groups of 2. We can make 7 groups of 2, but then we have one leftover block that we can't share out. So because we've made 7 groups of 2 with one left over, our answer is 7 remainder 1. Now notice there's a pattern here. 4 times 2 is 8, plus 3 is 11. 5 times 3 is 15, and then 15 plus 3 is 18. And 2 times 7 is 14, and then from 14 we need one more, we need to add 1 to get to 15. Also, another rule is that the remainder has to be less than the divisor. So if we're dividing by 4, our remainder can only be 1, 2 or 3, because if we had a remainder of 4, we'd be able to make another group. So if we're dividing by 5, our remainder can only be 1, 2, 3 or 4, and if we're dividing by 2 and we get a remainder, the remainder can only be 1. Otherwise, we'd be able to make another group. And without using blocks, the way to solve these is to think about your times tables. So, in the 4 times table, we need to find the closest number to 11, which is still less than 11. The closest number that's less than 11 is 8, and because 2 times 4 is 8, we know that 2 must be the number before the remainder. But then 2 times 4 is 8, and we need to think how many more from 8 do we need to get to 11. From 2 times 4 is 8, we need 3 more to get to 11, and that's why our remainder is 3. For 18 divided by 5, we need to think of a number in the 5 times table which is close to 18 but not more than 18. The closest number in the 5 times table is 15, and because 3 times 5 is 15, we know that 3 must be the number before the remainder. But 3 times 5 is 15, and then to find the remainder, we need to count on from 15 to get to 18. 15 plus 3 is 18, so that's why our remainder is 3. And for 15 divided by 2, we need to think of a number in the 2 times table which is as close to 15 as possible but not more than 15. The closest number to 15 in the 2 times table is 14, and 7 times 2 is 14, so we have 7 before the remainder, but 7 times 2 is only 14, and we need 1 more to get to 15, so that's why our remainder is 1. We can also show remainders on a number line. So because we're dividing by 4, we can count up in 4s, 4, then 8, and then the next multiple of 4 is 12. But that's too many because we were only dividing 11. So we need to stop at 2 jumps of 4, and then from 8 we need another 3, not another 3 jumps of 4, but just another 3 to get to 11. And that's why our answer is 2 remainder 3, because we can make 2 jumps of 4, but then we need 3 more to get to our dividend. Now, for 18 divided by 5, we can show jumps of 5. So we have 5, 10, 15, but then if we jumped another 5, that would be 20, but 20 is too many. So we need to stop at 3 jumps of 5, and then to get to 18 from 15, we need 3 more. We need to add 3. So here, because we made 3 jumps of 5 and then needed to add 3, our answer is 3 remainder 3. Now, for 15 divided by 2, we can jump in 2s. So we have 2, 4, 6, 8, 10, 12, 14. Now we can't jump to 16 because we can't go past the dividend. We can't go past the number we're dividing by. So we need to stop at 7 jumps of 2, but then from 14 we need to add 1 to get to 15. So because we made 7 jumps of 2 and then needed 1 more, our answer is 7 remainder 1. We can also show remainders using a sharing model of division. So remember, division can be 2 different things. It can be making groups, like we've done here, but it can also be sharing. So for 11 divided by 4, we can share out 11 counters between 4 groups. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. But remember, with division, we need our groups to be equal. So these 3 counters can't be shared out. That means that we have 2 counters in each group, and then 3 that can't be shared out. So that's why our answer is 2 remainder 3. Now we can share out 18 counters into 5 groups. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. Again, we have the problem that we need equal groups when we're sharing. So these 3 counters can't be shared out. We have 3 counters in each group and 3 remaining. So we have 3 remainder 3. Now let's share out 15 counters between 2 groups. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. But this counter here can't be shared out because we need to make sure that we have groups of the same size. So now we have 7 counters in each group and 1 remainder. So we have 7 remainder 1. Now let's learn our division facts for the 6 times table. 0 divided by 6 is 0. 6 divided by 6 is 1. 12 divided by 6 is 2, because if we have 12 counters, we can make 2 groups of 6. 18 divided by 6 is 3, because if we have 18 counters, we can make 3 groups of 6. 24 divided by 6 is 4. 30 divided by 6 is 5. 36 divided by 6 is 6. 42 divided by 6 is 7. 48 divided by 6 is 8. 54 divided by 6 is 9. 60 divided by 6 is 10. 66 divided by 6 is 11. And 72 divided by 6 is 12. Now let's learn our division facts for the 7 times table. 0 divided by 7 is 0. 7 divided by 7 is 1. 14 divided by 7 is 2, because if we have 14 counters, we can make two groups of 7. 21 divided by 7 is 3, because if we have 21 counters, we can make three groups of 7. 28 divided by 7 is 4. 35 divided by 7 is 5. 42 divided by 7 is 6. 49 divided by 7 is 7. 56 divided by 7 is 8. 63 divided by 7 is 9. 70 divided by 7 is 10. 77 divided by 7 is 11. And 84 divided by 7 is 12. Now let's learn our division facts for the 9 times table. 0 divided by 9 is 0. 9 divided by 9 is 1. 18 divided by 9 is 2, because if we have 18 counters, we can make two groups of 9. 27 divided by 9 is 3. 36 divided by 9 is 4. 45 divided by 9 is 5. 54 divided by 9 is 6. 63 divided by 9 is 7. 72 divided by 9 is 8. 81 divided by 9 is 9. 90 divided by 9 is 10. 99 divided by 9 is 11. And 108 divided by 9 is 12. Now let's learn our division facts for the 11 times table. 0 divided by 11 is 0. 11 divided by 11 is 1. 22 divided by 11 is 2, because if we have 22 counters, we can make two groups of 11. 33 divided by 11 is 3, because if we have 33 counters, we can make three groups of 11. 44 divided by 11 is 4. 55 divided by 11 is 5. 66 divided by 11 is 6. 77 divided by 11 is 7. 88 divided by 11 is 8. 99 divided by 11 is 9. 110 divided by 11 is 10. 121 divided by 11 is 11. And 132 divided by 11 is 12. Now let's learn our division facts for the 12 times table. 0 divided by 12 is 0. 12 divided by 12 is 1. 24 divided by 12 is 2, because if we have 24 counters, we can make two groups of 12. 36 divided by 12 is 3, because if we have 36 counters, we can make three groups of 12. 48 divided by 12 is 4. 60 divided by 12 is 5. 72 divided by 12 is 6. 84 divided by 12 is 7. 96 divided by 12 is 8. 108 divided by 12 is 9. 120 divided by 12 is 10. 132 divided by 12 is 11. and 144 divided by 12 is 12. Now here we have some missing number multiplication and division problems, but these first two questions aren't really missing number problems at all. That's because all we have on this side of the equal sign is an answer box, and it doesn't matter whether the equal sign comes at the start of the calculation like it does here, or at the end of a calculation like it usually does. We do the same thing. So 6 times 6 is 36. Here, again, we only have an answer box on this side of the equal sign, so we just do the calculation. 63 divided by 9 is 7, because 7 times 9 is 63. Now we have 7 times something equals 42. Whenever we have a missing number in a multiplication problem, we can use division to find our missing number. So we can divide 42 by 7. That's 6. So our missing number is 6. 7 times 6 is 42. Now we have something times 12 equals 108. Again, because it's a missing number multiplication, we can use division to find our missing number, and 108 divided by 12 is 9, so 9 times 12 is 108. Now we have something divided by 11 equals 9. Now remember, division problems can be read backwards as multiplication problems. So to find our missing number, we can multiply 9 by 11. That's 99. So we know that 99 divided by 11 must be 9. Now here we have 56 divided by something equals 7. So in this question, it's the divisor, or the second number in the division, that's missing. And when we have a missing divisor, we still use division to find our missing number. So we need to divide 56 by 7. That's 8. So our missing number is 8. And we can check 7 times 8, if we read the question backwards, is 56. Now let's take a closer look at some of these questions. What times 12 is 108? Well, we solved this by dividing 108 by 12 to get 9. So we know that 9 times 12 is 108. Now what we can show to represent this is a multiplication triangle. So we have 12 and 9 at the bottom and 108 at the top. And from one triangle, we can infer 4 different facts. We know that 12 times 9 is 108, and 9 times 12 is also 108, because if you multiply the numbers on the bottom in any order, you get the number on the top. Now we also know that 108 divided by 9 is 12, and 108 divided by 12 is 9, because if you divide the top number by one of the numbers on the bottom, you get the other bottom number. Now we could show this on a number line by counting in jumps of 12. So if we keep on jumping in 12ths, the 9th jump will take us to 108. So 9 is our missing number. Then we had something divided by 11 equals 9. We know that division problems can be read backwards as multiplications, and 9 times 11 is 99. Again, we could show a multiplication triangle with 99 on the top and 11 times 9 at the bottom. So from this triangle, we know that 11 times 9 is 99, and that 9 times 11 is also 99. And we know that 99 divided by 11 is 9, and 99 divided by 9 is 11. And we can show what we did here by counting up in steps of 11 until we get to 99. The 9th jump of 11 will take us to 99. So 99 divided by 11 is 9. Then we had 56 divided by something equals 7. Now because it was the second number, or the divisor, that was missing, we still used division to find our missing number. 56 divided by 7 is 8. So we can show a multiplication triangle with 56 at the top and 8 and 7 on the bottom. From this we know that 8 times 7 is 56 and 7 times 8 is 56. We also know that 56 divided by 8 is 7 and 56 divided by 7 is 8. Now to show this calculation on a number line, we can count on in steps of 7 until we get to 56. And because the 8th jump takes us to 56, we know that 56 divided by 8 must be 7. Now here we have some division problems, and for these divisions we're going to get remainders. And that's because 20 is not in the 6 times table, 24 is not in the 7 times table, and 64 is not in the 9 times table. So what we can do is count up in steps of 6 on a number line. So we have 6, 12, 18, and then if we made another jump of 6, we would get 24. But that's too many because we're only dividing 20. So we need to stop at 3 jumps of 6, and that takes us to 18. Now from 18 to get to 20, we need 2 more. Not 2 more jumps of 6, but just another 2. So our answer is 3 remainder 2. That's because we made 3 jumps of 6, but then we needed 2 more to get to 20. Now we have 24 divided by 7, so we can count in steps of 7. We have 7, 14, 21, but then if we made another jump of 7, that would take us to 28, and that would be too many. So we need to stop at 3 jumps of 7, which takes us to 21. Then from 21, we need to think, how many do we need to count on to get to 24? Well, 21 plus 3 is 24, and that means our answer is 3 remainder 3. That's because we made 3 jumps of 7, but that only took us to 21, and from 21 we needed another 3 to get to 24, so that's why our remainder is 3. Now we have 64 divided by 9, so let's count up in steps of 9. 9, 18, 27, 36, 45, 54, 63. Now if we added another jump of 9, that would take us to 72, but we were only dividing 64. So we need to stop at 63, and then from 63 we just need 1 more. We need to add 1 to get to 64. So our answer is 7 remainder 1. That's because we made 7 jumps of 9, but that only took us to 63, and from that we needed 1 more to get to our dividend to get to 64. So that's why our remainder is 1. Notice 3 times 6 is 18, then from 18 we need 2 more to get to 20. 3 times 7 is 21, then from 21 we need 3 more to get to 24, and 7 times 9 is 63, then from 63 we need 1 more to get to 64. So rather than counting on a number line, the way to solve these mentally is to think, what's the closest number in the divisors times table to the dividend, which is still less than the dividend? So here, for this first question, we could think, what's the closest number to 20 in the 6 times table that's still less than 20? Well, that's 18, and 3 times 6 is 18, so we know that 3 will be before the remainder in our answer. But 3 times 6 is 18, and we were dividing 20. So from 18, we need 2 more to get to 20, and that's why our remainder is 2. For this question here, we needed to think of a number in the 7 times table that's as close to 24 as possible, but not more than 24. That's 21, and 3 times 7 is 21, so we write a 3 before the remainder. But 3 times 7 is 21, and we need to count on 3 or add 3 to 21 to get to 24. So that's why our remainder is 3. Then, for this last question, we needed to think of a number in the 9 times table that's as close to 64 as possible, but not more than 64. That's 63. And because 7 times 9 is 63, we know that we have a 7 before the remainder. Now from 63, we need to add 1 or count on 1 to get to 64, and that's why our remainder is 1. So let's show these questions on a number line. First, we had 20 divided by 6. We counted up 6, 12, 18, but then we couldn't jump to 24 because we can't go past our dividend. From 18, we just needed to add 2 to get to 20. So now our answer is 3 remainder 2, because looking at it this way, we've made 3 groups of 6 and we have 2 left over. Or looking at it the other way, we've divided 20 into 6 groups. We have 3 counters in each group and 2 that we can't share out. So that's why we have 3 remainder 2. The next question we looked at was 24 divided by 7. That was 3 remainder 3, because we could count 7, 14, 21. We knew that going to 28 would be too many, so we stopped at 21, then added another 3 to get to 24. Now looking at what we have this way, we've shared 24 counters into groups of 7. We have 3 groups and 3 that we can't share out, so we have 3 remainder 3. Or if we were dividing by splitting 24 into 7 groups, we would have 3 in each group and then 3 that were remaining that couldn't be put in a group. Our last question was 64 divided by 9. We can count up 9, 18, 27, 36, 45, 54, 63. Going to 72 would be too many, but from 63 we just need to add 1 to get to 64. Now our answer is 7 remainder 1, because if we make groups of 9, we can make 7 groups and then have 1 counter left over, 1 counter remaining. Or if we're splitting 64 into 9 groups, we can have 7 in each group, but again there's 1 that we can't put into a group, so that's why we have 7 remainder 1. Now for these questions, we need to divide a multiple of 10, so a number that ends in a 0, by a single digit number. So first, we have 420 divided by 7. Now if we ignore the 0, we can spot that 42 is in the 7 times table. 42 divided by 7 is 6, because 6 times 7 is 42. So our answer is 60, because 42 divided by 7 is 6, but then if we have an end 0 in our dividend, we will have an end 0 in our quotient. Now we have 360 divided by 6. That's 60 as well, because 36 divided by 6 is 6. That's because 6 times 6 is 36, but again, if we have an end zero in our dividend, we will have an end zero in our quotient. So now we have 720 divided by 9. We can spot that 72 is in the 9 times table. 72 divided by 9 is 8, because 8 times 9 is 72. And then, again, if we have an end zero in our dividend, we will have an end zero in our quotient. And that makes sense, because 720 is 72 tens. So if we divide that by 9, we'll have 8 tens, or 80, as our answer. We can show the division on a number line. Now we know that one way of showing division is by counting up in steps of the divisor until we reach the dividend. But it would take us a long time to count up in steps of 7 until we got to 420. So instead of counting in sevens, we can count in steps of 10 times 7, so in steps of 70. Remember, our answer was 60 because 42 divided by 7 is 6, and if there's an end zero in the dividend, we need an end zero in the quotient. But on a number line, we can show this by counting in jumps of 10 times 7, so in jumps of 70. We have 70, 140, 210, 280, 350, and 420. So, because we made 6 jumps of 10 times 7, we made 60 jumps altogether, and that's why our answer is 60. To count in steps of 70, we just have zeros on the end of our 7 times table. Then, our next question was 360 divided by 6. That was 60 because 36 divided by 6 is 6, and then we need our end zero. On a number line, we can show this by counting up in steps of 10 times 6, so in steps of 60. We have 60, 120, 180, 240, 300, and then 360. So we made 6 jumps of 10 times 6, so that's 60 jumps altogether. And again, we can spot counting in steps of 60 is the same as counting in steps of 6, but with a 0 in our ones digit. Then we had 720 divided by 9. That's 80 because 72 divided by 9 is 8, and then we need our end zero. But to show this on a number line, instead of counting in steps of 9, let's count in steps of 90, so in steps of 10 times 9. We have 90, 180, 270, 360, 450, 540, 630, and then 720. So we've made 8 jumps of 10 times 9, so we've made 80 jumps altogether, and that's why 720 divided by 9 is 80. And again, counting in steps of 90 is just like counting in steps of 9, but with zeros in our ones. Now we need to divide a multiple of 100, so a number that ends in 2 zeros, by a single digit number. First, we have 600 divided by 2. That's 300, because 6 divided by 2 is 3, and then if we have 2 end zeros in the dividend, we will have 2 end zeros in the quotient. Now we have 3,500 divided by 5. That's 700, because 35 divided by 5 is 7, and again, if we have 2 end zeros in the dividend, we need 2 end zeros in the quotient. And that makes sense, because in the number 3,500, we have 35 hundreds. So if we divide those 35 hundreds into 5 groups, we'll have 7 hundreds in each group. So now 2,700 divided by 3. That's 900 because 27 divided by 3 is 9 because 9 times 3 is 27. And again, we need 2 end zeros in our answer. So for this first question, 600 divided by 2, we know that one way to divide is to count up in steps of the divisor until we get to our dividend. But it would take us a long time to count up in steps of 2 until we got to 600. So instead, let's count in steps of 100 times 2, so in steps of 200. We have 200, 400, then 600. So, because we counted steps of 100 times 2 3 times, we counted 300 steps. Remember, counting in steps of 200 is like counting in steps of 2, but with 2 zeros on the end in our tens and ones. Now, for 3,500 divided by 5, we can count in steps of 100 times 5. So 100 steps of 5 would take us to 500. Another 100 steps would take us to 1,000. Then 1,500, 2,000, 2,500, 3,000, and 3,500. So we counted steps of 100 times 5 7 times, so we counted 700 jumps altogether. Now, again, you can see that counting in steps of 500 is just like counting in steps of 5. So now, for 2,700 divided by 3, we can count 100 steps of 3 to take us to 300. Another 100 steps of 3 would take us to 600, then 900, 1,200, 1,500, 1,800, 2,100, 2,400, and then 2,700. So counting in steps of 300 is just like counting in steps of 3. And we can see that we've made 100 jumps of 3 9 times, so that's why our answer is 900. Another way to show the division would be to count in steps of 200 using place value counters. So if we have 200, 400, 600, you can see that we've got 600 counters altogether, and if we divide them or arrange them into 2 lines, we get 300 in each line. So now, for 3,500 divided by 5, we can count in 500s. That's 500, 1,000, 1,500, 2,000, 2,500, 3,000, 3,500. So we have a total of 3,500 because we've got 3,500s, but you can see in each of our 5 lines we have 700 counters, so that's why our answer is 700. Now 2,700 divided by 3, let's count in 300s. 300, 600, 900, 1,200, 1,500, 1,800, 2,100, 2,400, and 2,700. So, because we've got 2,700 counters altogether, we've got 2,700, and you can see in each of our 3 lines we have 900 counters, so that's why our answer is 900. Now let's divide using expanded division. So first we have 486 divided by 3. So we can set the question out like this, with our divisor on the left. First, we need to start by dividing the numbers or the digits in the larger place values. So first, we need to divide 4 by 3. Now the closest number in the 3 times table to 4, which is still less than 4, is 3. So we write the multiples of 3 underneath, and because 3 is 1 times 3, we write 1 in our answer. above the 4 because that's the digit that we were dividing. Now we need to subtract and bring down. 4 minus 3 is 1, and we can bring down the 8, so we have 18 divided by 3. Well, 18 is in the 3 times table, and because 18 is 6 times 3, we write 6 in our answer line. Now, again, we subtract and bring down our last digit. But 18 minus 18 is 0, so here all we need to do is bring down the 6, so we have 6 divided by 3. So now that we've brought down the last digit, we can just divide 6 by 3, and we know that that's 2, so we can write 2 in our answer. But to make it clear that we don't have any remainder, we can still subtract to get 0. So this 0 here tells us that we don't have a remainder, so our answer is up here. Our answer is 162. Now we have 581 divided by 7. Well, 5 is less than 7, and when the first digit is less than the divisor, what we can do is take the first 2 digits together and divide 58 by 7. So we need a number in the 7 times table which is as close to 58 as possible, but not more than 58. Well, 56 is in the 7 times table, and because 56 is 8 times 7, we can write an 8 in our answer line. So now we subtract and bring down. 58 minus 56 is 2, and we can bring down the 1, so we have 21 divided by 7. Now 21 is in the 7 times table, so we can either write 21 below, or we can just write 3 in our answer line, because 3 times 7 is 21, and we don't have any more digits to bring down. But to show that we don't have a remainder, we can subtract 21 and get 0. So our answer is 83. Now we have 592 divided by 8. Again, the first digit is less than the divisor, so we can take the first 2 digits together. We need to think of a number in the 8 times table which is as close to 59 as possible, but not more than 59. That's 56, and because 7 times 8 is 56, we write 7 in our answer line. Now we subtract and bring down. 59 minus 56 is 3, and we can bring down the 2, so we have 32 divided by 8. Well, 32 is in the 8 times table, and because that's 4 times 8, and we don't have any more digits to bring down, we can just write 4 in our answer line, and we have our answer. But if we want to show that there's no remainder, we can subtract 32 and get 0. So our answer is 74. Now let's look back at this first question. We started with 486, so that's 4 hundreds, 8 tens, and 6 ones, and we were dividing by 3, so we can share our place value counters into 3 groups. First, we found that we could share out 3 of our hundreds, but then we had 100 left over. What we were really doing here isn't bringing down the tens, but changing our 100 into 10 tens, because we can exchange 100 place value counter for 10 tens. And so that's how we get the 18 down here, because we now have 18 tens. And we can share out all 18 of those tens. So now we brought down the 6 because all we needed to do was share out our 6 ones. And now you can see that in each of our groups we have 100, 6 tens and 2 ones. So that's why we get 162 as our answer. Then we had 581, so 5 hundreds, 8 tens and 1 one, and we were dividing by 7, so we can share these counters out into 7 groups. We took the first 2 digits together, and we can do that because 5 hundreds and 8 tens is the same as 58 tens, because we can exchange each of our 100 counters for 10 tens, And when we do that, that gives us 50 extra tens, so we have 58 tens altogether. Now we can share out 56 of those tens, and that's why we wrote 56 below. But we had 2 remaining tens. What we can do is exchange one 10 counter for 10 ones, and that's why we then had 21 to share out. We can share out all 21 of those ones, and because in each of our groups we now have 8 tens and 3 ones, we have 83 as our answer. Then we had 592 divided by 8. So that's 5 hundreds, 9 tens and 2 ones, and we're sharing these counters into 8 groups. Again, remember when the first digit is less than the divisor, we take the first 2 digits together. And we can do that because if we exchange each of our hundreds for 10 tens, you can see that we now have 59 tens altogether. So we can share out 56 of those tens. And we have 7 tens in each group, so that's why we have a 7 as the tens digit of our answer. Now we have 3 remaining tens, but we can exchange each of those 10 counters for 10 1 counters, and that gives us 32 ones. When we share those out, we get 4 ones in each group, so that's why we have a 4 as the ones digit of our answer. Now let's divide using short division. First, we have 486 divided by 3. So we can set the question out like this with our divisor on the left. Now when we're dividing, we start by dividing numbers or digits in the larger place values. So first, we need to divide 4 by 3. So what we need to think of when we divide is a number in the divisors times table, so a number in the 3 times table that's as close as possible but not more. Now the closest number to 4 in the 3 times table is 3, and because 3 is 1 times 3, we write 1 in our answer. But 1 times 3 is 3, and we need to count on 1 or add 1 to 3 to get to 4. So our remainder is 1, and we can write the remainder in front of the next digit. So now we have 18 divided by 3. Well, 18 is in the 3 times table, and because 18 is 6 times 3, we can write 6 in our answer line. And we don't have a remainder because we were dividing a number that's in the divisors times table. So now we just have 6 divided by 3. That's 2 because 2 times 3 is 6, so our answer is 162. Now we have 581 divided by 7. Now here we can see that the first digit is less than the divisor. So either we could write 0 remainder 5, or what I like to do is to just take the first 2 digits together and divide 58 by 7. Again, when we're dividing, we need to think of a number in the 7 times table that's as close to 58 as possible, but not more than 58. The closest number in the 7 times table is 56, and because 56 is 8 times 7, we write 8 in our answer line. But 8 times 7 is 56, and we were dividing 58. So from 56, we need 2 more to get to 58. 56 plus 2 is 58, so we have a remainder of 2. And as always, we write the remainder in front of the next digit that we're going to divide. So now we have 21 divided by 7. 21 is in the 7 times table, and because that's 3 times 7, we write 3 in our answer line. So our answer is 83. Now let's try 592 divided by 8. Again, the first digit is smaller than the divisor, so we can take the first 2 digits together and divide 59 by 8. So we need to think of a number in the 8 times table that's as close to 59 as possible, but not more than 59. Well, the closest number in the 8 times table is 56, and because that's 7 times 8, we write 7 in our answer line. But 7 times 8 is 56, and we need 3 more to get to 59, so 3 is our remainder. So let's check. 7 times 8 is 56, plus 3 is 59. So now we just need to divide 32 by 8. 32 is exactly 4 times 8, so we can write 4 in our answer line to give us our answer of 74. Now let's look back to this first question. We started with 486, so that's 4 hundreds, 8 tens, and 6 ones, and we were dividing by 3, so we can share these place value counters out into 3 groups. We started by dividing our hundreds digit, so our 4 hundreds. We can share out 3 of those hundreds, and that gives us 100 in each group, so that's why we have 1 as the hundreds digit of our answer. But now let's think about why we could write the remainder in front of the next digit. Well, that's because we can exchange our 100 counter for 10 tens. So that gives us 18 tens altogether, and that's why we could write our remaining 100 in front of our tens digit, because now we have 18 tens. We can share out all of those tens, and we have 6 tens in each group, so that's why we have 6 as the tens digit of our answer. So now we just share out our 6 ones, and we get 2 ones in each of our groups to give us our answer 162. Then we had 581, so that's 5 hundreds, 8 tens, and 1 1. We can take the first 2 digits together, and we can do that because we can exchange each of our 100 place value counters for 10 tens, and when we do that, we get 58 tens altogether. Now we can share out 56 of those tens, and that gives us 8 tens in each group, so 8 as the tens digit of our answer. But then we have 2 tens that we can't share out. We have a remainder of 2 tens. But we can write that remainder in front of our ones digit, and we can do that because we can exchange each of our 10 counters for 10 ones, and that gives us 21 ones to share out. When we do that, we get 3 ones in each group to give us our answer 83. Then we had 592 divided by 8, so that's 5 hundreds, 9 tens, and 2 ones, and we can share these counters into 8 groups. Now, again, we took the first 2 digits together, and we can do that because 100 counter has the same value as 10 10 counters. So now we have 59 tens. We can share out 56 of those tens, and we have 7 tens in each group, so that's why we have 7 as the tens digit of our answer. But then we have 3 tens that we can't share out, because remember, when we're dividing, we need to create equal groups. But we wrote our remainder 3 in front of the ones digit, and we did that because the 3 remaining tens can be exchanged for 30 ones, so that gives us 32 ones altogether. When we share those out, we get 4 ones in each group, so 4 is the ones digit of our answer, 74. Now we have some missing number multiplication problems, but this first question isn't really a missing number problem at all. That's because all we have on this side of the equal sign is an answer box, and it doesn't matter whether the equal sign comes at the start or at the end like it usually does. We do the same thing. We just need to multiply 164 by 6. So we can set this out as a short multiplication. 4 times 6 is 24, so that's 2, 4, with the first digit above the next digit that we're going to multiply. Then 6 times 6 is 36, but we need to add the 2 that's on top. So 6 times 6 is 36, plus 2 is 38. So we need to write that 3, 8, with the first digit above the next place value column along. So now 1 times 6 is 6, plus 3 is 9. So our answer is 984. Now we have 3 times something equals 522. So here we have a missing number multiplication. And whenever we have a number missing in a multiplication question, we can always use division to find our missing number. So we need to divide 522 by 3. First, 5 divided by 3 is 1 remainder 2. That's because 1 times 3 is 3, and then we need 2 more to get to 5. Now, 22 divided by 3 is 7 remainder 1. That's because 7 times 3 is 21, then from 21 we need to add 1 to get to 22. So now 12 divided by 3 is exactly 4, because 4 times 3 is 12. So our missing number is 174. Now something times 9 equals 504. Again, if we have a missing number in a multiplication, we always use division to find our missing number. So we just need to divide 504 by 9. Now if we look at the first digit, 5 is less than 9. So what we can do is take the first 2 digits together and divide 50 by 9. 5 times 9 is 45, but then from 45 we need 5 more to get to 50. 5 times 9 is 45, plus 5 is 50. So now we have 54 divided by 9. That's exactly 6, because 6 times 9 is 54. So our missing number is 56. Now we have some missing number division problems. But this first question isn't really a missing number problem at all, because all we have on this side of the equal sign is an answer box, and it doesn't matter whether the equal sign comes at the start of the calculation, like it does here, or at the end, like it usually does. We do the same thing. We just need to divide 596 by 2. So we can use short division. 5 divided by 2 is 2 remainder 1. That's because 2 times 2 is 4, and then from 4 we need 1 more to get to 5. Now we have 19 divided by 2. That's 9 remainder 1, because 9 times 2 is 18, then we need 1 more to get to 19. So now we have 16 divided by 2, which is 8, because 8 times 2 is 16. So our answer is 298. Now 632 divided by something equals 8. Well, here it's the second number, or the divisor, that's missing. And when the second number in a division problem is missing, we still need to use division to find our missing number. So we need to divide 632 by 8. If we look at the first digit, 6 is less than 8. So what we can do is take the first 2 digits together and divide 63 by 8. Well, 7 times 8 is 56, but then from 56 we need 7 more to get to 63. 7 times 8 is 56, and 56 plus 7 is 63. So we get 7 remainder 7. So now we have 72 divided by 8. That's exactly 9, because 9 times 8 is 72. So our missing number is 79. Now something divided by 9 equals 304. So here it's the first number of our division question, or the dividend, which is missing. Now division problems can be read backwards as multiplication problems. So to find our missing dividend, we can multiply 304 by 9. So if it's the second number of the division that's missing, we still divide to find our missing number. But if it's the first number that's missing, we multiply. 4 times 9 is 36, so that's 3, 6, with the first digit written above the next place value column along. 0 times 9 is 0, plus 3 is 3, and 3 times 9 is 27. So our missing dividend is 2,736. Now we're going to divide by chunking on a number line, and for these questions we're going to get remainders. Now first we have 69 divided by 2. We can tell straight away that we're going to get a remainder because all multiples of 2 end in 2, 4, 6, 8 or 0, and we have 69. Now one way to divide is to count up in steps of the divisor until we reach the dividend. But it would take us a long time to count up in steps of 2, so let's make 10 jumps of 2. That would take us to 20. If we made another 10 jumps, we would get 40, and another 10 would take us to 60. Now another 10 jumps would take us to 80, but that would be too many. So now let's just make jumps of 2. We have 62, 64, 66, 68, and then the next jump of 2 would take us to 70, but that would be too many. So from 68, we need one more, not one more jump of 2, but just another 1 to take us to 69, so to take us to our dividend. So let's think about what we've jumped altogether. We've jumped 10, 20, 30, 31, 32, 33, 34 jumps of 2, and then we needed another 1. So our answer is 34, remainder 1. Now we have 124 divided by 3. So let's jump in steps of 10 times 3, so in steps of 30. We have 30, 60, 90, 120. Then, if we just jump another 3, that would take us to 123, but then we would need one more to get to 124. So we jumped 10, 20, 30, 40, 41, and then we needed another 1. So our answer is 41, remainder 1. Now we have 135 divided by 4. If we jump in steps of 10 times 4, so if we make 10 jumps of 4, that would take us to 40. Another 10 fours takes us to 80. Then another 10 takes us to 120. Now what we can do next is just jump in steps of 4. So 124, 128, 132. Then to get to 135, we need another 3. So our remainder is 3. So altogether we've jumped 10, 20, 30, 31, 32, 33, and then needed another 3. So our answer is 33, remainder 3. So for this first question, we had 69 divided by 2. So we've got 6 tens and 9 ones. We can share out our tens to get 3 tens in each group. Then we can share out 8 of our ones to get 4 ones in each group. This one is a remainder because remember, with division, we need to make equal groups. So this block here can't be shared out. So our answer is 34, remainder 1, because we have 3 tens and 4 ones, so 34 in each of our groups, but then we have one block that can't be shared out, so that's our remainder. Then we had 124, so 100, 2 tens and 4 ones, and we were dividing by 3. Now we can't share out this 100 block, because again, when we divide, we need to make equal groups. But what we can do is split our 100 into 10 tens. Then we can share out our tens to get 4 tens in each group. We can share out 3 of our ones to get 1 1 in each group, but we can't share out this 1 here because we need equal groups when we divide. So our answer is 41 remainder 1 because we have 4 tens and 1 1 in each group, and then we have 1 that we can't share out, so that's our remainder. Then we had 135 divided by 4. So that's 100, 3 tens and 5 ones, and we're sharing these blocks into 4 groups. Again, we can't share out our 100 because we need equal groups, but we can exchange our 100 for 10 tens. So now we can share out 12 of those tens to get 3 tens in each group, but we can't share out this 10 because we need to make equal groups. What we can do is exchange this 10 for 10 ones. So now we can share out our ones. We can share out 12 ones to get 3 ones in each group, but we can't put these 3 ones into groups because then this group here wouldn't have as many, and when we divide, we need to make equal groups. So our answer is 33 remainder 3 because we have 3 tens and 3 ones in each of our groups, but then we have 3 that we can't share out. Now we're going to divide using expanded division, but for these questions we're going to get remainders in our answer. First, we have 69 divided by 2. Remember, when we divide the larger place values first, so we have 6 divided by 2. Well, 6 is in the 2 times table, so we can write 6 below, and because that's 3 times 2, we write 3 in our answer line. Now we subtract and bring down. 6 minus 6 is 0, so all we need to do now is bring down the 9, and we have 9 divided by 2. Now we've got to the end, we don't have any more digits to bring down, but 9 is not in the 2 times table. The closest number to 9 in the 2 times table, which is still less than 9, is 8. So we can write 8 under the 9, and because 8 is 4 times 2, we write 4 in our answer line. Now we subtract, and 9 minus 8 is 1, and we don't have any more digits to bring down, so this 1 is our remainder. So our answer is 34 remainder 1. Now let's try 124 divided by 3. If we look at the first digit, 1 is less than 3, so we can take the first 2 digits together and divide 12 by 3. 12 is in the 3 times table, so we can write that underneath, and because 12 is 4 times 3, we can write 4 in our answer line. Now we subtract and bring down. 12 minus 12 is 0, so we just need to bring down the 4. So we have 4 divided by 3. Now the closest number to 4 in the 3 times table is 3, so we write that underneath, and because 3 is 1 times 3, we write 1 in our answer line. Now we subtract. 4 minus 3 is 1, but we don't have any more digits to bring down, so this 1 is a remainder, so our answer is 41 remainder 1. Now we have 135 divided by 4. Again, the first digit is less than the divisor, so we can take the first 2 digits together. We need a number in the 4 times table, which is as close to 13 as possible, but not more than 13. The closest number to 13 in the 4 times table is 12, and because 12 is 3 times 4, we write 3 in our answer line. So now we need to subtract and bring down. 13 minus 12 is 1, and we can bring down the 5, so we have 15 divided by 4. Now we need a number in the 4 times table that's as close to 15 as possible, but not more than 15. That's 12, and 12 is 3 times 4, so we write 3 in our answer line. Now 15 minus 12 is 3, and we don't have any more digits to bring down, so this 3 is a remainder. So our answer is 33 remainder 3. So for this first question, we had 69 divided by 2. We could share out all 6 of our tens, so we wrote 6 below the 6, and because that gave us 3 tens in each group, because 6 divided by 2 is 3, or 3 times 2 is 6, we could write 3 in our answer line. Now we had to subtract, which was 0, and we could bring down the 9. So now we were dividing our 9 ones. We could share out 8 of those ones, so we wrote 8 below the 9, and because 4 times 2 is 8, we could write 4 as the ones digit of our answer, because we have 4 ones in each of our groups. But we can't share out this 1 here, because when we divide, we need to make equal groups. So this 1 is our remainder. 9 minus 8 is 1, and that tells us that we have a remainder of 1. So our answer is 34 remainder 1. In each of our groups we have 3 tens and 4 ones, but then we have 1 remainder which we can't share out. Now 124 divided by 3. What we could do was not share out our 100, but rather split our 100 into 10 tens. That gave us 12 tens, and we could share out all 12 of those tens, so we wrote 12 below the 12, and because 4 times 3 is 12, we could write 4 in our answer line, because we have 4 tens in each of our groups. Then we needed to subtract and bring down. 12 minus 12 is 0, but we could bring down the 4. Now if we try to share out these 4 counters, we can put 1 counter in each group, so share out 3 of our ones, and because we have 1 1 in each group, we can write 1 in our answer line, because 1 times 3 is 3. But we can't share out this 1, because when we divide, we need to make equal groups. So 4 minus 3 is 1, and that tells us that we have a remainder of 1. So our answer is 41 remainder 1. Our last question was 135 divided by 4. Again, we can't share out our 100 because when we divide, we need equal groups. But if we split our 100 into 10 tens, we now have 13 tens, and that's why we could take the first 2 digits together. Now we can share out 12 of those tens, and because we have 3 tens in each group, because 3 times 4 is 12, we can write 3 as the tens digit of our answer. But we can't share out this 10 here because we need equal groups. So we did 13 minus 12 to get a remainder of 1, and then we brought down the 5, so we had 15. What we can do is split our 110 into 10 ones, so now we're sharing out 15 ones. We can share out 12 of those ones, and we have 3 ones in each of our groups, because 3 times 4 is 12. But now we can't share out these 3 ones, because when we divide we need equal groups. 15 minus 12 is 3, and that tells us that we will have a remainder of 3, so our answer is 33 remainder 3. Now we're going to divide using short division, but for these questions we're going to get remainders in our answer. So first we have 69 divided by 2. We can set the question out with the divisor on the left, And first, we need to divide 6 by 2. That's 3 because 3 times 2 is exactly 6. So now we have 9 divided by 2. That's 4 remainder 1 because 4 times 2 is 8, but then we need 1 more to get to 9. So our answer is 34 remainder 1. Now we have 124 divided by 3. If we look at the first digit, 1 is less than 3. So what we can do is take the first 2 digits together. 12 divided by 3 is 4 because 4 times 3 is exactly 12. But now we have 4 divided by 3. Well, 1 times 3 is 3, but then we need 1 more to get to 4. So 4 divided by 3 is 1 remainder 1. That means our answer is 41 remainder 1. Now 135 divided by 4. Again, the first digit is less than the divisor, so we can take the first 2 digits together and divide 13 by 4. The closest number to 13 in the 4 times table is 12, and because 12 is 3 times 4, we can write 3 in our answer line. But 3 times 4 is 12, and from 12 we need 1 more to get to 13, so we need to write our remainder 1 in front of the next digit. So now we have 15 divided by 4. 3 times is 12, so we have 3 as the ones digit of our answer. But 3 times 4 is only 12, and we were dividing 15. From 12, we need 3 more. We need to count on 3 to get to 15. So that's why we have a remainder of 3. Our answer is 33 remainder 3. Now let's look at this first question again. We had 69 divided by 2. First, we shared out our 6 tens. And when we did that, we got 3 tens in each of our groups because 3 times 2 is 6. But then we needed to share out our 9 ones. We could share out 8 of those ones, and we got 4 ones in each group, so the ones digit of our answer was a 4. But we can't share out this remaining one, because when we divide, we need to make equal groups. So this one here is our remainder, and we could tell that we were going to get a remainder, because 4 times 2 is only 8, and we were dividing 9. 4 times 2 is 8, and we need 1 more, that's this 1 more here, to get to 9. So our answer was 34 remainder 1. Then we had 124 divided by 3. We can't share out this 100, because when we divide, we need to make equal groups. But what we can do is exchange our 100, or split our 100, into 10 tens. That means that we have 12 tens to share out, and we can share out all of those tens. We get 4 tens in each group because 4 times 3 is 12. But now we need to share out our 4 ones. We can share out 3 of those ones to get 1 1 in each group, so that's why we have 1 as the ones digit of our answer. But we can't share out this remaining one because we can't have one group with 42 and others with only 41. We can't share out this block here, so this is our remainder 1. That's why our answer is 41 remainder 1, because we have 4 tens and 1 1 in each group, but then we have 1 that we can't put into a group. Finally, we had 135 divided by 4. Again, we couldn't share out our 100, but we could split our 100 into 10 tens, and that means that we have 13 tens altogether. We can share out 12 of those tens, but we can't share out this 10 because we need the same amount in each group. So, because we have 3 in each group, we have 3 as the tens digit of our answer. But then we have 1 10 that we can't share out, so we write this 1 remainder in front of the next digit. So now we have 15, so 1 10 and 5 ones, that we need to divide by 4. To do that, we can exchange our 10 for 10 ones. We can share out 12 of those ones to get 3 ones in each group. But we have 3 left over, and we can't share these out because if we did that, then this group here wouldn't have as many. So we have a remainder of 3. 3 times 4 is 12. That's the 12 ones that we've shared out. But then from 12, we need 3 more to get to 15. And that's the 3 that we can't share out. So our answer is 33 remainder 3.